We've come to Bosch Sensor Tech to learn about a breakthrough in particulate matter sensing. The product is the BMV080, and we're going to meet Ahmed Elbadry to tell us more about it. So this is the BMV080. It's a tiny particulate matter sensor. This is typically what people will be using today, this size of device. This is the new one. Ahmed is going to tell us all about it. So here we're going to talk about your product, which is Fanless. It's incredibly small compared to what people will be used to using today. You're going to explain to us a bit later how you've managed to do this with some pretty clever technology. But first, this is a particulate matter sensor.
Yes.
Tell us a bit about particulate matter sensors. So what do they do? What's the principle of operation, and what kind of devices are they found in today?
So the BMV080 is, as you said, the particulate matter sensor. So it's an optoelectronic sensor.
Yep.
It measures PM 2.5 particulate matter. It gives mass concentration values.
And to be clear, PM 2.5, so that's referring to the particle size.
It's actually the diameter of the particulate. So it measures diameter of a particulate smaller than or equal to 2.5 micrometers.
And typically you get PM sensors that measure maybe PM 10, PM 2.5, PM 1.
And this sensor actually measures both PM 2.5 and PM 1. So that means also it can distinguish between less than or equal to 1 micrometer in diameter, and also less than or equal to 2.5 micrometers in diameter. We are going to also support featuring in the future very soon PM 10 as well.
PM 10, and so these are tiny particles that are in the air around us, in the air that we breathe. Why is it important to measure the concentration of these particles in the air that we breathe?
Yes. So as you mentioned, PM 2.5 is particularly dangerous because it gets into our lungs. Without us, it gets through our nostrils. They're so small that you cannot really see them, but they get into our respiratory system.
So
and
larger particles get absorbed by the in the nose and the nasal passage before they get to the lungs.
They get into the lungs. But 2.5, less than or equal to 2.5 micrometers are particularly dangerous, and they are characterized as a very harmful source of that actually damages the health. So in certain areas, it depends on the area, but these are generated typically from fumes of fire or traffic or typical things, also cooking events at home. So I have, for example, a PM sensor at home, and it would go crazy when I go cooking.
Right.
So and you might be inside working in your office, which is a completely different room, and you already feel that it's getting bad. You need to open up the windows because of, and just having the sensor there to give you a signal helps quite a lot.
Yeah, and the health effects that are associated with prolonged breathing of high concentrations of these tiny particles. What kind of things can you find?
To reduce health, the life, so the age expectancy.
Right.
So lowering the age, how long longevity of a person lives.
So we really don't want to be breathing this stuff.
Definitely.
This dirty air is a definite bad thing. Okay. So there have been particulate matter sensors sort of available on the market for many years. The basic principle of operation is sort of shining light into the air and seeing what comes back.
So basically, it's laser scattering technique where you have a laser beam emitted from the sensor, and these interact. So they interact with the particulates in the air. The backscattering light that comes back is then calculated, and from there you get an estimate or a measurement basically of the particulate matter. This is an absolute measure.
So to put it in simple terms, the more of these particles that you've got in a volume of air, the more light is going to be scattered back to the photodiode, and
this
therefore
is then calculated, and then you get a measurement of mass concentration.
Okay, and that measurement of mass concentration is expressed as what? As micrograms
per meters cube.
Per meter cube. Okay, all right. Good. So this is how these sensors do that, perform that function. So this is the kind of device that people will typically be using today. It's our pin box, but this is around the size of a particulate matter sensor module that people are using today. This here, on the end of my finger, really hard to see, but that's your product, much smaller. Why is this one
This
so
is
big?
this
Why
is
is this one so small?
450 times smaller typically than a
450.
conventional
Yeah,
PM
yeah,
sensor, which
yeah.
is a huge leap
Yeah.
in technology.
So people who are using these things, why does this thing have to be so big today?
The thing is, it's easier to have constants to work with so that you don't have a lot of variables that you need to deal with when it comes to the algorithm. That's basically what they do. They have an enclosure, they have a fan that pulls in the air, there's an inlet and an outlet, and then measuring inside. So they control the environment, they control a lot of constants, and that helps them do the algorithm with less complexity.
Yeah. So the reason that this thing is so big is not so much because the electronic sensor itself is large. It's actually a pretty small part, but this is creating a controlled chamber with an air inlet, with a fan that's passing air over the sensor at a known controlled flow rate. And that's why you need this enormous thing in order to do particulate matter measurements today with the simpler algorithms that these sensor modules are using. So how have you got rid of the box, the fan, the air inlet? What's going on with this thing that means you don't need all of this size?
Well, it's all about the algorithm. So what we done is we made a very clever software algorithm, and this is where we got to deal with all the different factors, and it was quite complicated, but we are able to precisely measure PM 2.5 and also
in free space. So
free space.
no controlled airflow, no chamber. It's
You don't
just
need mechanical airflow. You don't need an inlet, and you don't need any move. There's no moving parts, no enclosure, which makes the sensor quite unique.
And so all you need, because it's, as we've described, an optical sensor, it's got a laser and a photodiode. You just need an aperture on the surface of whatever your product is, so that they can see out into the air.
Into the air. So the sensor just needs to look into the air, and based on that, they do what they do.
And the size of the aperture on the product needs to be
roughly a meter, 1 millimeter.
1 millimeter diameter. Okay, all right, very good. So here we are. We've got this very small sensor. No fan, no chamber. What does that mean for someone who's designing a product that this might go into? It could be something wearable. It could be a smart thermostat. That kind of product. What are the advantages now that you've got rid of the box and the fan and the chamber?
So as you said, so it's fanless. That means also it's noiseless, so it doesn't generate any noise.
So no noise is one of the
it's
actually
a big
one of the benefits.
advantage, as this can be quite a hurdle. Well, you hear the product it would annoy the end user in a way. So also the sensor is by design also dust proof, and it can be integrated in a waterproof device as well.
So getting rid of the fan means you've got a silent device. It's not
dust-proof,
not exposed to dust. Yeah, absolutely.
It can be designed into waterproof design as well. And also the size advantage, making it compact and possible to integrate into much smaller devices as well. Like wearables.
So let's talk then about where you can see this tiny device being used in what kinds of products might we find this in?
Some of these are compact IoT devices. It's very common to have it. Nowadays, IoT devices are integrating more and more sensors inside, and they're getting smaller and smaller. So you can find these in compact IoT devices. You have also air monitors, which can be on your tabletop or maybe wall mounted as well. But there's also smart thermostats, which monitor the indoor air quality. They're becoming more and more advanced and adding new features.
So those might be integrated into a smart home automation into ventilation systems. So that when this detects that there's dirty air, it can then trigger the ventilation system to start.
Control ventilation, HVAC systems, all that. You can have a multitude where air quality is important and the sensor is taken care of. But also It can be a wearable device now
Okay,
because
yeah.
it's so
Well,
small.
so small, absolutely will
So
fit,
you
won't
can
it?
have
Yeah.
it on your
Yeah.
wrist, you can have it on your shoulder, you can integrate it into many different use cases.
Okay, all right. And people even, I think, are investigating the way that this could be integrated into a smart mask.
Yes, exactly. So in some cases, you can also have it in very unique applications, like a smart mask, as you to detect the air quality that you inhale outside, and then you can also detect inside what after going through the filtering. So distinguishing between good and filtered air.
Okay,
as well.
very good. So you've got these really clever algorithms that are enabling, for the first time, this kind of optical device to measure particulate matter concentrations in free space, in free air. Is it doing it with the kind of level of accuracy that you need in order to be able to take intelligent decisions about ventilation and air purification and so on?
We have tested our sensor against analytical devices costing tens of thousands and so on,
Yeah.
and we see that it's precisely consistent, but this one costs much less.
Yes. The output that your sensor produces is it's a digital output.
So actually, we have an SDK. So you get an output of PM2.5, the mass concentration, and PM1, and as I said, it will also support PM10.
Yeah.
So this is
Okay.
what you would be getting.
Okay.
Digital.
And
Yeah.
so that's produced as a
Digital
measurement in terms of
the
micrograms per meter
communication
cubes.
is done I2C SPI. So
Right. Okay. So compatible with any normal microcontroller. Or,
Yeah.
Yeah. Okay. Very good. I've been picking this device up.
Yes.
You're going to tell
About
me
that.
that I've yes.
should not do that.
I shouldn't. So I've broken the first rule of using
Yes.
of using your
So,
product, haven't I?
yes.
So we're gonna. So viewers can go and see a separate video that talks about the issues around
will-
handling integrated.
will
But basically, I shouldn't be picking this up. That's
Yes.
the
sensor is typically handled, as you see, there's a stiffener on
Yeah.
the sensor.
Yeah.
And you're supposed to handle that with a tweezer or a vacuum pen.
Okay.
And you're not allowed to touch any other part of the whether it's a flex PCB or components or the sensor part, you're not allowed to touch any of that.
Okay. All right. Okay. Great. I understand. So I've done the wrong thing, but
It's
you'll
okay.
get.
We can play with it since it's already gone.
Yeah. All right. Okay. All right. So here we are. I'm doing the wrong thing with the sensor, but if you're interested in using this sensor, in evaluating it, then there are shuttle boards available for you to do that. And also go and see our separate videos that are about integration of this device and how you handle it. Clue: you don't handle it like this. So there's a ton of reasons why you'd be interested in exploring the features of the BMV080 particulate matter sensor, and you can do so with one of the shuttle boards. So Ahmed, maybe you can tell us, we've got can see the board here, you've got the sensor. I see it's behind an aperture with there's a dark ink glass and some headers and then some connectors underneath. So just tell us, how do you use this BMV080 shuttle board?
So the shuttle board is meant to be an early evaluation and also for proof of concept. You will find basically it connects to our application board, similar to our other shuttle boards which we have in our product portfolio.
So an application board is a board with a microcontroller on it and that can connect to a PC.
Also you can use it for BLE communication, so
Right,
it has
okay.
a lot of features supported, and you can use it then for proof of concept. So you either use our drivers, we have readily available examples on GitHub, and additionally you can also plug and play. So we have also software supporting plug and play, where you can just plug and test the sensor and see outputs.
Okay, so you can plug this shuttle board into either one of your application boards or into your own proof of concept board, and you've got full software support for it as well, with PC and for support on a PC and application examples through GitHub and so on.
Yes.
And this board is available for anyone who wants it now?
Yes, and you can get it through our distribution partners.
Thank you.